Hello, I'm Sammy Archibald, student founder of Stun, and today we're going to be showing the Adafruit Motor Shield version 2. Last video we just installed the library and got you set up with the Arduino IDE. This time we're going to be using the Motor Shield itself. If you haven't seen that video, click down in the description. It's down there. It'll be whatever. Down in the description. And so yeah, let's get started. So you need a shield, a board, a motor. That's it. So go. I want to point out a couple of things on this board because they need to be pointed out. Alright. So if we come up here, manual zoom, or manual focus rather. So there's a jumper right there. There's a jumper. So what you can use external power with this device. What you want to do is you want to always leave it disconnected if you're using external power. The only reason why you'd ever have it connected with a jumper is to have it just to have it use the voltage in pin on the Arduino. So if you have like a 9-volt battery pack connected to the Arduino and you want it to use that, but we're just gonna like have it hang off one pin because I'm using external power, and if you're in the workshop, you should be doing it too. All right, so this right here, all this stuff, that's where the transceiver connects. That's not a part of this board. We're not doing anything with that this tutorial, so don't worry about that. And then that's just a communications chip right there, and then these two are drivers, and then these are just all screw terminals for various things, you know, breadboard holes and or protoboard holes and etc. etc. So let's get started. Focus that. All right. So you're going to take the shield, plug it into the Arduino, just like that. Just like any other shield. Then we're going to take our external power over here, and then we need a screwdriver. I believe this is a screwdriver I've been using. I've been having a bit of a screwdriver problem with the shield. We go ahead and we put positive power into the plus. There you go. I'm going to take ground. Connect to the negative pin on here. There we go, just like so. Screw that baby down. And there we go. So now we got the power. You should see the power LED light up. You haven't seen that? Alright, so this is powered, but the Arduino isn't. So we need to go ahead and we need to connect a USB cable to it. Right here. Go ahead and plug USB in. There we go. So now both things have power, and we're going to actually switch over to the computer. Okay, first thing we're going to do over here is we're going to go here, Electronics, Arduino IDE, which just open up however you open up the Arduino IDE on your computer. It's different depending on the operating system. I'm running Ubuntu with XFCE interface. Alright, so we're going to go to File, Examples. I named it Adafruit MSV2. But we're going to go to DC Motor Test. This is called the TikTok program. I will always refer to it as the TikTok program, and you'll see why in a second. Alright, so we're going to go here. It's all good. So this is motor. Which motor is this? Get motor 1. So we're going to do it. So this is just, we're going to be using motor 1, which on the shield it shows M1, M2, M3, M4. We're going to go here. We're going to upload. Compiling. And there we go. So now we're going to switch over here. And so what I'm going to do is I'm actually going to disconnect the Arduino so it doesn't move the motor while I'm trying to do this. But you find M1. M1 is right here, M2, then M3 and M4. And go here, and we're going to take M1 screws, and those are already pulled out. Connect one part of the motor there. That right in tight. Take the other motor 1 terminal, and there. Go ahead, screw it down, real tight, real good. There. So now we can plug it in. Alright, there we go. So you can hear the motor going back and forth, 6 volts. That's just the basics of the shield. That's all you do for getting it right up and running, just going back and forth. So if you don't have a motor, you can actually still test out the code and the shield and all of that. So you just go here, or if you don't have access to the motor, if the motor is somewhere and you can't tell where it's going, you can actually switch over to the computer. You go to serial monitor, and you can go tick, talk, tick, or tech. But anyway, it goes back and forth whenever the motor changes direction. This is why it's called the tick. This is why I call it the tick-tock sketch. I'm going to turn that off. Close that. So yeah, that's the basics of just getting it right up and just moving the motor around, just kind of go back and forth. Now we're going to go ahead and we're going to look into the code. So you scroll up, include wire.h, so that's I2C. Include Adafruit motor shield.h, which is the obviously the motor shield code. Include and then utility / Adafruit PMM servo driver.h. That's just for if you want to drive a servo on this thing, because you can drive servos on the board. But create motor shield object with the default I2C address. So you have to have this line, so it recognizes what the Arduino shield is. Select which port you're using. In this case, M1. So yes, this is the DC motor. My motor is motor 1. So if we go here, we go my motor. See, so this is like int, except it's a lot more complicated. But basically, you type in Adafruit / DC motor, and then you type in what you want it to be named. Star, then what you want it to be named, and then which motor it is. So if I wanted to also have one that was motor 2, I could do Adafruit DC motor. If did I spell it right? F-U-R-I. Okay, cool. And then bam, my motor. If you want to call it like your motor, is equivalent to AFMS dot get motor to. There we go. So that's just saying that no, I didn't spell Adafruit right. It's good. F-R-U-I-T. There we go. Not with two T's. There we go. Okay. And then if we get uppercase motor. There we go. So now whenever you call your motor, it'll say motor 2. If you get that. Void setup serial begins. This is starting the serial. So with the serial monitor, there'll be a serial video coming shortly. When I'm done doing that, I'll go ahead and put it down in the description. Print line, and then it's just talking about it's just talking about the motor shield. And set the speed to start from 0 off to 255 max speed. You want to set my motor, which is motor 1, to 150. My motor run forward, which turns it on and makes it go. Start spinning forward, not backwards, but forwards. Then turn on the motor, motor run release, which I believe release is sort of just like it stopping, like putting 5 volts on each pin, but I'm not too sure about that. Void loop, have that in. Then serial.print tick, and like I said, serial video coming soon. Run the motor forward. It goes through. This is just a bit more complicated code. It's just talking about, it's just setting the different speed, setting how long it's going and different speeds and all that. Basically, it's just saying motor set speed to I. It's doing all this work to up here. It's just doing math to tell how long and all that to run the motor. You can just set like, my motor set speed delay 10. That'd be the simpler way to do it, but serial print talk, my motor run backwards, run the motor backwards, and then tech, which means to release it, and then delay 1 second. So release, like I said, is just, not putting a voltage on or putting 5 volts on both. So hopefully that makes sense. There's forward, backward, and release, which most of those are self-explanatory. You talk with my motor, and you have to have lines like this to tell what each motor should do. And that's it. You just have a couple of proprietary lines of code. This is how to set. I taught you how to set what each line or set each line. So now we're going to go ahead and we're going to create our own little sketch. Go. Actually, I could have just gone to new. Just hit one of the new things, but go here. You can just make this a bit. Nope. Got a bit bigger. Okay, so we can just go here. Just copy and paste this. It's, why copy? And again. Alright, so now we can do something similar to this. We want motor 1, except you know what, I'm feeling rebellious, so I'm actually going to call it, not my motor, but I'm going to call it motor. Just to show you how to edit the code. In void setup, basically all of this you want to have. You should always have stuff that's like gets the motor started, just like half speed or something like that, going forward, and then you should just release it, because you always want to have it just release. All right, so oh yes, an AFMS is actually frequencies. So you can have the frequency of the motor change. Actually, if you find the right frequency with your motor, you can actually change the efficiency of the motor and how much noise it makes. All right, so serial begin. We don't want it to say this. We don't want it to say serial. I want to say yo. Let me go here and my motor. Turn on the motor. Blah blah blah. So it's not called my motor anymore, is it? It's called motor. 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 Cool. So now we have the setup, and we have it just, going through the whole shebang. And then let's just go void loop. Create our loop, and then go allow us to use serial dot print. We need to do capital S serial dot print. Call it forwards. Then we can go motor dash greater than set speed, or nope, we want to run it backward. Set the spelling. Backward. There. So that's saying run it backwards, not forwards, and it's just a polarity thing, because it works in H bridge. But usually it's good. It's good to have a backwards and a forwards to have it. So if you're like maybe building a car like this, you can always. It takes a second to get all the pins right, but once you set the motor correctly, it'll move along pretty well. You can just tell, which way it's going. And motor, bam, bam, set speed. Let's set it to. I think you can set it up to 255. Yeah. So let's. You know what? YOLO 255. And then we should do a delay. 1 second. And serial dot print. See, look at this. I got forwards and backwards. That is just wrong. Serial dot print front motor run forward and motor dash run or set speed. Let's do 100 on 1 5. And then we can go ahead and just do a delay of a second, and motor run release. Oh. Release, and then motor set speed, and then I think do we need a set speed? No, we don't. Okay, cool. I wasn't sure if we need a set speed or not with release. I was pretty sure that we didn't, but I was just going. We can do a serial print again. Just serial.print stopping delay 2 1 2 3. Sweet. So basically what we did here is we go and we set the, here we go, AMFS begin, that's setting the frequency to the usual 60 Hz. It's telling you what the I2C location is, or data is, which stuff to include. Serial begin, this is beginning the serial communication at the 9600 baud rate, say yo. Set the speed to 150 at forward, then release it, then go back, wait a second, forward, wait a second, stop, wait 2 seconds, and then end the code. There, so that's basically how to use the code, and there's also going to be a new tutorial on the code, just programming Arduino. We're going to have something nice and special to program that isn't related to the workshop, just to introduce certain aspects of code. I'm going to go ahead and we're going to upload. We are compiling, and valid loop expected in 23.3. Alright, let's go to what's that, right? 28. Let's go 28. Oh, right here. Verify it. So yes, there'll be a video on serial communication and programming shortly. This is just showing you specifically the... Oh, I forgot to plug the Arduino in. Just showing you specifically programming this shield. Uploading. There we go. Back, front. Stopping. Back, front. Stopping. Back, front. Stopping. Back, front. Stopping. And you probably can't tell on the camera, but it is in fact spinning back and forth. So there you have it. That's how to use the shield with DC motors. It's a bit different with other stuff, and like the stepper motors and the servo motors, but that's just an introduction, guys. Thank you for watching. Leave a comment if you have a question about anything I've done in this video. Leave a thumbs up if you like it, thumbs down if you dislike it, and subscribe if you're in the workshop or you're curious about the workshop, or you're curious about anything that we do outside and you want to get more content similar to this. Anyway, see you, well, I'll see you in the next video. Hopefully we'll be either programming or just basic workshop stuff. Alright, so see you in the next one, guys. Bye.